Let us look at characteristics of a group. Now we have looked at axioms of a group. When can we call a set under an operation as a group? We have looked at the axioms, closure property, existence of identity, existence of inverse, and closure property. But here we are looking at a little bit more about these axioms in terms of characteristics. So basically, based on the axioms, these are things additionally that we can say about a group. So let's say we have a group and let G be the set of elements and star be the group operation in general. And to be able to say it fluently, we just read it as types, whatever be the type of operation it is. So now we know existence of identity is an axiom. So here we are saying identity is unique. That means there is only one identity in a group. So for all A in G, A times E is equal to A is equal to E times A. So which means since it is unique, it means if A times E1 is equal to A is equal to E1 times A, then E1 is equal to E. Inverse is unique. See, in a group, inverses exist. Otherwise, they are not a group. So for all A in G, A inverse times A is equal to E is equal to A times A inverse. So given an element A, there can't be more than one inverse. Now, inverse law. Now, suppose we are taking the inverse of a product of two elements. Then what happens? So for all A and B in G, the inverse of A times B is equal to B inverse times A inverse. So here the order is changing. Okay. Now left cancellation law. If A times B is equal to A times C, then B is equal to C. So here what this left cancellation law says is that if we have a situation like this, we can, instead of evaluating it fully, we can just directly cancel off A, which means there must be a right cancellation law as well. So if A times B is equal to C times B, then A is equal to C. So here B and B are getting cancelled. This is, you have to be very clear about what we are saying here. If it is A times B is equal to B times C, then B and B need not be cancelable. It would be cancelable only if the group is abelian. If it is non-abelian, then it would not be cancelable. So in general, we say left cancellation law and right cancellation law. So be very clear about these two, left cancellation law and right cancellation law. That is why A is on the left of B and C. And here B is on the right of A and C. Okay, so that brings us to solvability of group equations. What that means is A times X equal to B and Y times A is equal to B each have a unique solution. A times B is equal to A and B times A is equal to A implies B is equal to E, the identity. So, which means we can have an alternative definition of a group. A set G with a binary operation star is a group if the operation star is associative and for all A and B in G, the equations A times X is equal to B and Y times A is equal to B has a unique solution. Because this would cover all these characteristics. Because to solve for X, you will have to multiplied by the inverses. And that will lead to the identity. And if you do something on this side, you will have to do on this side, and you will end up with a solution. X equal to something. Similarly, y equal to something. And here, A and B can be any element in the group. So that was characteristics of a group. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.